Hello everyone, myself Venu, lecturer in mechanical engineering from Government Polytechnic Varangal, and subject dealing is refrigeration and air conditioning. And today's topic or today video lesson is on Electrolux refrigerator. So today lecture goes on Electrolux refrigerator, and just we recall all the topics what we have covered in the last video class. So mostly we are concentrated on the a particular topic, that is a practical vapor absorption refrigeration system. In the previous, before this video class, this practical vapor absorption refrigeration system video class, we have seen the ideal vapor absorption system. So practically how efficient it is and how economical it is. So all those things we have seen in the previous video class, and we have also seen some regarding the properties of the ideal refrigerant and the properties of absorbent, and combination of both the refrigerant and absorbent. So whenever they combine each other, and what are the properties or getting in that when the combination is taking place. So all the properties we have seen for different cases, and also we have seen the commonly used refrigerant absorbent pairs. We have listed out some refrigerant and absorbent pairs by combination of that, and what is the state of absorbent of a particular thing. It may be solid or it may be liquid. So all the things we have seen with some examples. So hope you have understood that topic, and with the same spirit we are entering into the next topic. We will see the objectives. So here hope so you will learn, or you will understood after completion of this period, this video lesson, you may be able to understood the following topics. So that is regarding mostly concentrating on a single the component, that is Electrolux refrigerator. So principle and operation of Electrolux refrigeration, that is the first thing. And next we will see the what are the advantages and what are the disadvantages of Electrolux refrigerator. Mostly is used in a domestic purpose also, this Electrolux refrigerator, and other name for this, it may be called like a three fluid system or three fluid refrigerator. So why the name is given like that, we will see in that case. And if you see the previous video lesson or a previous video topic, that is regarding the vapor absorption system, what we have seen, mostly you seen the two fluids are there in that, means one is a refrigerant and other one is absorbent. In the same similar case, here this Electrolux refrigerator is called as a three fluid system. So why it is named, and what are those three fluids, and what are the principle behind that, what is the advancement they have made when compared with the vapor absorption refrigeration system. It is also works on the same principle, but just a little modifications was made to this Electrolux refrigerator, and we'll see what are the advantages and disadvantages. So clearly, if you see in the topic, the discussion of this particular topic, so we can clearly understood what is the modifications made in the some vapor absorption system, and why it is called as a three fluid system Electrolux refrigerator. Right. So just first look the line diagram of Electrolux refrigerator. Just you observe all the components what are present. Compare with the previous video class. What are the components present in this, and what are the other components additionally made in this. So you can just you observe for some time, and you can get some clarity regarding on this line diagram compared with the previous cases. Just if you observe some of the names, you can list out them. Like there is a generator, just to compare with the vapor absorption refrigeration system, and the burner in the sense to provide some heat. The fluid which is present in the generator, we are providing the burner, and the generator already is present in the vapor absorption system, and water separator is specially placed here, just like we have seen in the vapor absorption system, practical vapor absorption system, there is analyzer and rectifier. Those are particularly placed for removing the water content or removing the moisture moisture content in the vapor refrigerant. And you can see other component like a condenser. So the same connections are same. How the flow is taking place from one component, the series of connections are same again, from generator to next main component connected to the condenser, then next condenser to here we are not providing the expansion valve. So let us see what is the importance. We are not providing the expansion valve here. Then next to the condenser we are connecting to a U trap. Then next U trap to the pipe connection is moving to the evaporator component. So next we have the absorber also here. So in between the absorber and generator there is a heat exchanger. And if you observe here, we are not providing a pump here. So this is the main explanation in this particular topic, Electrolux refrigerator. We are eliminating the pump. So purely it is making without the use of any mechanical components, more complete absence of the noise, or complete the clearance of it. No vibrations are there in any components. So to avoid completely, so pump is also not using here. So without the help of a pump, how the refrigerant is sending into the components or to the generator. So we can see all these things in the Electrolux refrigerator. So similarly all the components are there, just how they are placed, how they are arranged is in a different way. That's it. And here you can see in the connection to the evaporator to the absorber, there is a flow of hydrogen is present in the evaporator. We will see what is the purpose of hydrogen also. In most case this Electrolux refrigerator, these are the listed out components, like a absorber, a heat exchanger, generator, water separator, condenser, a U trap is provided, just like a U type of section, and one evaporator component is there, and hydrogen is present in that. We'll see what is the importance of hydrogen. And inside the component we have to use a refrigerant, most commonly used refrigerant, again the same case as a vapor absorption system, that is we are using ammonia. And to that one absorbent must and should be there, that is water. Ammonia is one substance, one fluid, and the water is one substance or fluid, and hydrogen is other substance or fluid. So three fluid system. One is refrigerant, the one is absorbent, and other one is one just like one gas or one inert gas. Okay, so one is ammonia, water, and hydrogen. Hydrogen is inert gas, and water is absorbent, and ammonia is a refrigerant. So three fluid system is used in the Electrolux refrigerator, and how it is functioning, what is the principle behind that, we will see it clearly. So hope you have taken this the line diagram of Electrolux refrigerator, just how the connection, how the pipelining system is there, and which components are connected, you can see clearly in the line diagram. Next, so just look at a few points regarding this system. So just explain that it works on three fluid absorption system. You just note down the point. What are the three fluids? One is ammonia, refrigerant, water as absorbent, and hydrogen as inert gas. Here what is the main purpose? I already told, we are completely eliminating the vibrations or anything. We are completely making like a noiseless. So we are eliminating the pump here. So without the pump, how the refrigerant is pumping into the generator component, we'll see that clearly. Next, this refrigerator, this Electrolux refrigerator is free from moving parts. So no moving parts, no vibration, so it is a noiseless completely. Now here, what are those three fluid systems we see? One is ammonia, refrigerant, and water is absorbent, and next hydrogen. Just you can note that sentence. So it is a pumping agent. So it is a pumping agent, so used to create low pressures to enable ammonia to evaporate at low pressures. So here, when I already told that hydrogen is present in evaporator, so what it will do is it enables the ammonia, whatever the ammonia came into the system with high pressure, without without use of expansion valve. What you're doing directly from the condenser along with the U trap is coming and entered into the refrigerant is coming and enters into the evaporator. So it should has to get evaporated. So low temperatures are created first of all. So what to create low pressures, we are using the hydrogen as a pump as an agent to enable ammonia to evaporate at low pressures. Okay, it will evaporate at low pressures, and must and should this it should insoluble in water. Hydrogen is insoluble in water, and it is non-corrosive in nature. Remember this thing, these 3 points. Right now we will see the working principle. Right here, what the same case, just what we have explained in the vapor absorption refrigeration system. Like we will start from the generator component. First, the strong solution, so which is present in the generator, so that must and should be heated up to increase its or to change the phase of a strong solution. So strong solution is a combination of the vapor, the ammonia and water. More the quantity of ammonia, it means uh, the some proportionate quantity. If you consider, if the more the concentration of ammonia is there, it is a strong ammonia solution, and this solution is present in the generator, and whenever it gets heated, so ammonia vapors are generated, or ammonia vapors are formed due to little addition of heat with the help of a burner. Ammonia vapors are formed in the generator at the top, and it is passed to the condenser, where it is passed through a water separator or through some analyzer or some through rectifier, where the water vapor particles are separated in that. So water separator is fitted before the condenser component. Now the ammonia vapors which are generated in the generator, though with the help of this due to addition of heat, with the help of that heat energy, the ammonia vapors are created, and with high pressure ammonia vapor will pass through the condenser through a water separator, where it additionally it is like a safety device to remove the moisture content. If not, the possibility it will chokes the pipe in the evaporator like that, due to low temperatures created. Next, so water vapor present in ammonia vapors separates in water separator to avoid choking of the system, just what we have discussed. So avoid choking of the, means pipelines are blocked at some high temperatures, the water vapor will become just like a solid form, and they may block the pipeline, just like choking of the system completely. System will get stopped. And here the ammonia vapor condensed to liquid in the condenser by the cooling medium. You know the very well, I think, the purpose of condenser. Some fins are placed around the condenser, so consider some air cooling medium. So air is making contact through the fins. So the purpose of the fins around the condenser is to provide like a more the area of contact is more. If you increase the contact area of the air with the condenser, then more the heat exchange will take place. So here the cooling medium considered like air is making contact. Now what happens, due to that heat exchange is taking place, ammonia vapor is condensed back to ammonia liquid. Okay, phase change is taking place in the condenser. You know all these points regarding the condenser, what is happening in the condenser. Condensation is taking place. Now next, to the condenser, so the pressure is remaining constant here. That high pressure liquid ammonia, by changing its phase, converts to liquid ammonia, that it enters here into the U trap first. So here a U tube is placed here, where gas seal is provided after condenser, so which prevents entry of hydrogen into the condenser. So just a simple purpose of this U trap or U tube is provided here. Whatever the hydrogen gas is present in the evaporator component, so it will try to enters. If it is a slant pipe or if it is a straight pipe here directly connected to condenser, there is a chance to enter the hydrogen gases into the condenser. So if you provide a U type of section or U tube of type gas seal hydrogen will not enter into the it will not pass through this section, and it will not enter into the condenser component. So entry of hydrogen is restricted with the help of this U trap. That is a simple purpose. Next, to the U trap, the pipeline is connected to the evaporator component. So here the thing, what the principle they are using, the liquid ammonia which is coming from condenser, they are not using any kind of by gravity pressure, whatever the gravity, its gravity is there. So the liquid ammonia from the condenser directly enters into the evaporator through the U tube just by gravity. Just to remember that point, that its gravity, it will come downwards and it enters into the evaporator component. Next, okay, the few things has to discuss here, that is regarding first, the thing is, the whole system is, first of all, it is charged to for some 14 bar. Just like here we are using the principle of some Dalton's law of pressure. Dalton's law of pressure, the principle we are using here. So the whole system is charged to 14 bar. Now whatever the evaporator containing the hydrogen, so it contains at a pressure of 12 bar. So whatever the hydrogen which is present in the evaporator, so it is maintaining or present at a pressure of 12 bar. Now the first the thing is, the whole system is charged to 14 bar. So whenever that ammonia is entering into the evaporator, so its pressure falls to 2 bar. So here not discussing the Dalton's law of partial pressures. What happens when there is a pressure differences like this? Charged system pressure is 14 bar and the hydrogen present in the evaporator has 12 bar. So when ammonia with that pressure, 14 bar pressure, ammonia enters into the evaporator, so its pressure falls to 2 bar, which already present in the system is 14 bar, falls to 2 bar according to Dalton's law of partial pressures. Now what happens here? Due to the sudden drop in the pressure, a very low pressures are created. You can see the 2 bar means very low pressures in the evaporator. The temperature of the liquid will also changes. So whatever the ammonia liquid is coming, that the temperature of that liquid ammonia is also falls to approximately at minus 18 degrees centigrade. Okay, minus 18 degrees centigrade, pressure drops to 2 bar. So that you can clearly see in the explanation of the principle of that Dalton's law of partial pressure. Due to the low pressures, temperature will also fall drastically to minus 18 degrees centigrade. Now we can utilize that temperature. What the principle in the evaporator, so evaporation will take place. It means whatever the ammonia liquid in the evaporator, so that absorbs the heat from the refrigerated space. What evaporator, nothing but consider some space is there inside the component. So whatever the products are placed inside the evaporator. So here that ammonia liquid, due to its low temperatures, it absorbs the heat from the products or substances placed in the refrigerated space. Now again it converting back to the vapor form, ammonia vapor. So it changes its state or phase from liquid to vapor. So you can see at the bottom the ammonia along with the hydrogen, it is entering into the absorber component. Now here the mixture of ammonia vapor and hydrogen enters into the absorber and mixes with the water coming from generator. So it mixes with the water. So mixes with the water coming from generator means, so ammonia mixes with the water here. So where the water is coming from the generator, you can see the connection here, the weak solution line which is passing through the heat exchanger at the top pipeline. If you see, that pipeline is entering into the absorber at the side. You can see at the left side of the absorber and right side of the generator there is a pipe connection. This weak solution is consisting of a combination of again the ammonia but more quantity of water. So whenever the concentration of this ammonia is less, so it is a weak solution, more the quantity of water is there. So it is making here that is coming and mixing with the ammonia here. Right, now here whatever the ammonia vapor is there already, which is coming from evaporator, so it mixes with, it is absorbed by the water in the absorber. Okay, it was absorbed by the water in the absorber. So that is the thing happening in the absorber. Next, the hydrogen rises up. So here, so whenever it is forming like some strong solution, whenever the affinity of both the hydrogen and the ammonia and the water mixing together, affinity is more, they mix very well, and during this combination the hydrogen gas will rises up, and again you can see the connection is provided at the top of the observer. It's making connection to the again to the evaporator. Hydrogen will falls again in the evaporator, so it get rises up and return to evaporator due to light in weight. Next, the strong solution of ammonia enters the generator. See the bottom connection of the absorber, there is a pipeline. So where here that strong solution enters into the generator. First it enters through the heat exchanger, then it enters at the top of the generator component. See how the cycle is completed, and till we can explain what is happening here in the heat exchanger. So here first the weak solution at the top of the circuit is moving through the heat exchanger, and the bottom circuit you can see the strong solution with the low temperatures are moving here. So during this the weak solution with high temperature, its temperature is given to the low temperature strong solution. So the strong solution is preheated in the heat exchanger, and that heat of that the temperature exchange will take place. The hotness of the weak solution gets reduced, and low temperature of the strong solution get increases. So here both the things are happening simultaneously here. So that is the use of heat exchanger. So cooling the whatever the cost of the cooling system is reduced in the absorber, and cost of the heating system in the generator gets reduces. So both the advantages are there by using the heat exchanger here. Now again what happens, whatever the strong solution entered into the generator component, again the same process will happen. The burner will get function here, again the vapors are generated, again the cycle is repeated. So this is how you are getting the cooling effect in the evaporator component. So due to the pressure differences obtained here, the hydrogen is doing its function, means it's how the low pressures are created with the hydrogen, that is due to the pressure differences. Already the system is charged due to 14 bar, and hydrogen which is present in the evaporator is 12 bar. So according to the Dalton's law of partial pressures, pressure drops to or pressure falls to 2 bar. So due to very low pressures created, so low temperatures are attained in that about minus 18 degrees centigrade. So again our target is achieved, that means low temperatures are created, so it is enough, the temperature whatever obtained in the evaporator, so that is enough for making anything. You can make the ice cubes also. Ice cubes can also be formed by because very low temperatures, about minus 18 degrees centigrade, right? So it can be used for some domestic purpose. So domestic Electrolux refrigerators are also manufactured and used in the households. So this is regarding three fluid system, how the use of three fluid system are utilized without the aid of the pump here. No need of a pump can be seen here. Now so just simple diagram here, just like you can see, this is a heat or generator where you are supplying the heat to the generator, and it enters into the separator here. Right, and whatever the gas is there, that vapor form or vaporized one, that vapor it enters into the, this is the solution, weak solution is entering into the absorber, and whatever the thing is there, that vapor, ammonia vapor will enters into the condenser component. So heat is rejecting in the condenser. At the top you can see the next is here it enters into the evaporator component. What happens here, due to present in this, it is converting back to the liquid due to low pressures created here. So here the condenser condensation is taking place, the liquid ammonia is entered into the evaporator. Due to low pressures created in the evaporator by the hydrogen, low temperatures are created. Here the heat is absorbed by the ammonia vapor. Again the same process is happening. So hope you have understood this Electrolux refrigerator, and let us focus on the advantages. So just by this theory concept, you can, I think, hope you can tell the advantages and disadvantages also. Just we'll proceed the one by one, the point wise we will see just what we have discussed. The advantages: one is a noiseless operation. Why? Because no vibrations out there in the refrigerator, so it is a noiseless operation. And cheap maintenance, it means the low cost of maintenance can be seen in the Electrolux refrigerator. So absence of walls, no need of walls, I think, no need of any walls, and in the sense just like compressor, if you use there are some walls are provided there, so some ports will be provided there. No need of all those things here, like a expansion wall also, no need of expansion wall, so they can be eliminated in this. No need of all these things. And then no lubrication problems. If more the mechanical components are present, we have to use more the lubrication to reduce its vibrations, uh, to reduce the noise. So no need of any lubrication, no lubrication is required. No chances of pressure unbalancing. Okay. And operates in absence of electric power supply. I hope you understood there is no supply of any electricity in this case. A little, for example, if, just like a burner, instead of a heater, if you use the electric burner, there is supply of electricity in there, or you can use directly the burner. So completely can eliminate the electric power supply. Okay. And a low grade energy system is sufficient to supply heat in the generator, hence solar energy is also used. Like its application of some solar panels can be placed here, or some solar any energy, the solar energy in terms of different applications where the heat is generating there. So low grade energy systems, just we have to supply some heat, we have to heat the solution, so it is a very less cost. So those are the advantages you can already seen. And next, the coming to disadvantages, it's not suitable for industrial purpose. It may be used for domestic, as already told, it's used in mostly in domestic usage purpose. Why? Because the temperature obtained in that with the help of the system, and like a minus 18 degrees centigrade, and industries, it needs a very larger quantity of if you use this system, minus 18 degrees centigrade, it's not a feasible one. And more the quantity of hydrogen you have to use that, and more the it may not be suitable for industrial purpose. And this is also one reason why they are not using like a low COP. Whatever the refrigeration effect you are giving, or you are getting, and compared to the input you are giving to that, so it is a low COP, so output may be very less. So what happens, obviously the low COP you are obtaining there, so not able to produce sufficient pressure differential for maintaining large flow rates. So this it means not able to produce sufficient pressure differential. It means whatever the fluid we are using, it means hydrogen, the third substance, whatever the hydrogen we are using here to reduce the pressures in the evaporator, so we are not providing much the pressure differences. The system is charged to 14 bar, and hydrogen it is maintaining at 12 bar, so getting 2 bar pressure differences only. So likewise we have to use different combinations of substances to get a different pressure changes. So already it is inbuilt used for particular substance, so we have to maintain only that particular pressure differences only can be maintained, so cannot produce different kinds of pressure differences there. Okay, so hope so today in this class we have seen the working principle of Electrolux refrigerator. And next we have seen the advantages and disadvantages of Electrolux refrigerator. So hope you have understood that topic regarding how the working is taking place, how the refrigeration effect you are getting. So a few questions to you, a few quiz questions to you. I think if you answer this, I hope you can have understood that topic very very much. So the question is, fluids used in Electrolux refrigerator are. So three fluid system it is. So the given answer is, it's a answer, right? It's ammonia, combination of water and hydrogen. And use of hydrogen in Electrolux refrigerator. So how the answer can be given here? So it acts like a pumping agent. If the pressure difference is created here by the hydrogen, so it itself it can be moved into the low pressures can be created in the evaporator. So very faster rate of evaporation can be obtained with the help of this hydrogen, and with the pressure difference created by the hydrogen, so no need of any pumps here. So it can itself move, the fluid can be moved into the generator component, no need of any pumps there. So it is a pumping agent. Next, the pressure of hydrogen in the system. It means like a pressure of hydrogen in this system, right? So charged pressure in the system is 14 bar, and hydrogen present in the evaporator, so it has a pressure of about 12 bar. And right, this is the answer, right? Hope that next question is function of U trap in the system. Already explained that there is a U type of shape, so it will completely it is placed for particular purpose, that whatever the hydrogen gas is there, it should not come back and enter into the condenser. It should be placed in the before the U tube or U trap, so that it should stop the return flow of the hydrogen. So it is present in the evaporator, then next it enters into the absorber, again absorber to evaporator, so it will circulates in these two components only. It should not come back to the condenser, so must and should U trap is placed. So that is the function of U trap. So this is regarding a few quiz questions to you. If you answered that, I hope you can understood it very easily. You can write. Now the frequently asked questions, like explain the working principle of Electrolux refrigerator with an 8 sketch. Okay, so just you can draw the what the earlier we have seen the diagram of Electrolux refrigerator, and you can explain the working principle, the component wise, or how the working is taking place, the component wise. And we seen number of advantages and number of disadvantages. The question is, what are the advantages and disadvantages of Electrolux refrigerators? You can write that. Already we have seen those points. So these are the few frequently asked questions in the examinations, right? So this is today's video topic, and if possible you can see the small video regarding this Electrolux refrigerator. I will provide that, and hope you have understood this topic. And this today's topic, that is Electrolux refrigerator. So we will see in the next video class regarding another topic. We can see by looking at other application regarding on the vapor absorption refrigeration system, that is lithium bromide. I will discuss in the next video class. So hope you have understood the today's video lesson, and you can answer that simple quiz, and you can practice that what are the frequently asked questions.